welcome back. Today we're going to be talking about using the celestial sphere in order to figure out not only maximum altitude, but what time your star will reach maximum altitude. And like I had said last time, you use declination and your celestial equator in order to find the maximum altitude of your star, and then use that to determine which direction your star is going to be in. Is it going to be north or south on the celestial sphere? And then what we're going to talk about is how to use right ascension in order to determine what time your star will reach its maximum altitude, which is really important. So let's do a quick review of finding the maximum altitude. Okay, so again, we are going to be found in Ruskin, Florida, which has a about 27 degree latitude. Okay, plus 10 gives us our celestial equator, which is 37 degrees. Okay. Alright, so moving on from that, let's do a couple examples before we really kick it off, okay? So let's use, number one, we'll be using Sirius, which has a right ascension, again, not important yet, of 6 hours and 45 minutes, but a declination of minus 16 degrees, okay? And we're looking for maximum altitude is equal to celestial equator plus declination. Okay, so we do 37 degrees plus minus 16, which gives us 21 degrees. Okay, that's our maximum altitude. And our direction here, our azimuth, is going to be, again, south, which is 180 degrees. Okay? And what you're going to be looking for here is, remember, maximum altitude, what direction? Okay? And so we'll move on later to talk about how this is going to come into play, but for now I really just want to review how to find maximum altitude because that's all important. So let's try another one. Let's do Mizar. Okay, so Mizar has a right ascension of about 13 hours and 20 minutes and a declination of about plus 56 degrees. Okay, so again, maximum altitude is equal to celestial equator plus declination, okay, which means 37 degrees plus 56 degrees, which is going to give us 93 degrees, okay? Can't have that, so we're going to do 180 minus 93, which is going to give us 87. Okay? And because we had to subtract by 180, our azimuth is equal to 0 degrees or north. Okay? Alright. Now let's go on and talk about time. Okay? Time is when we're going to be using our maximum altitude. Okay? So in order to do time, we're going to need both of these charts over here. So in order to find what time your star is going to reach maximum altitude, you are going to need these charts. Okay, this first one has to do with when the sun will be reaching maximum altitude. Okay, and it actually starts with the spring equinox. All right, spring equinox happens anywhere from March 20th to 23rd, most commonly happening around the 21st, which is why this chart in particular starts on the 21st. This will change every year. So if, let's say, spring equinox is on March 22nd, that means this will get fixed to represent March 22nd. But for all intents and purposes right now, we are just going to be using it as if it was March 21st, okay? Which means our sun will reach maximum altitude at with a right ascension of 0 hours, okay? And so let's say it's March 21st. We would be starting it here, 0 hours, okay? And we would go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23. Okay, so remember, this is a 24-hour clock. It goes 0 to 23 hours and 59 minutes, okay? So now let's say it's March 21st. Okay, so our right ascension for the sun is 0 hours, okay, and that's where we started our chart at. So now we have a star we're going to do it. Star A has a right ascension of 5 hours and 30 minutes. Okay? So we're going to look on here, and remember RA is right here on both of these, so let's look for 5 hours. 5 hours is right here, so that means it's going to be about 5 p.m. But look at that, we have an additional 30 minutes. That means 30 minutes past 5 p.m. Okay? So at 5:30 p.m., our star A will reach its maximum altitude. Okay? Well, what if I have some wonky date, okay? A date that doesn't quite make sense, right? Let's say we have a date anywhere from the 5th of the month to the 15th of the month, or sorry, the 8th of the month to the 15th of the month. Okay, there is a lot more math involved in this. I have simplified this to make it easier for students to do this at a much easier pace in class, because there is middle hours. You'll notice here that March 21st, April 21st, May 21st, it goes 0 hours, 2 hours, 4 hours. There is a point in here where you will get 3 hours, 1 hour. And so the date range that I use in my classes is from the 8th to the 15th, because it's simple, it's right in the middle of both of those, and it doesn't cause as much confusion. So if you're anywhere between this, you're going to be using that odd number. So if you're between, let's say, April 8th to April 15th, you would be using the 1 hour marker. Okay, if you're between December 8th and 15th, you would be using the 17-hour marker, because you'll be between November and December. If you are before this number, okay, let's say you're the 7th, you will be using the previous hours. So if you are April 7th, you will still be using March 21st, which would be 0 hours. What if you're after that? Well, let's say you are the 18th of the month. At this point, we will be using, again, we're using April 18th. We will be using the 2 hour point, okay? And that's just for ease. It's to make things a little bit easier in class rather than having them calculate the exact in-between numbers. I give them a little bit of a range. I don't know if this is what you do in your astronomy courses outside of mine, but this is what I do in here, and that's what we follow in all the labs that we do. Okay, so again, we're going to stick with the Ruskin date, Ruskin location, and I'm going to give you we're going to go over a couple stars in this aspect. Alright, so let's try, let's do our first one to be Vega. Okay, so we're going to start, number 1 is going to be Vega. Okay, Vega has a right ascension of 16 hours and 30 minutes, and a declination of plus 38 degrees. Okay, we are going to use the date that I recorded this, which is 4/13/2020. Okay, and 4/13 just happened to fall in between the 8th and the 15th of the month. So what we are going to be using for this, for April 4th to 15th, is the 2 hour marker, or the 1 hour marker. Okay, so we're at 1 hours, and so we're going to go ahead and just put that into our chart. So we've got it all the way from 1 to 24, or 0, okay? And so let's get started. First thing let's find the maximum altitude. So remember, maximum altitude is equal to declination plus celestial equator. So we've got 37 degrees plus 38 degrees, which is going to give us 75 degrees. Okay, that is our maximum altitude. What is the azimuth? What direction are we going to be hitting our maximum altitude? Well, since we didn't subtract by 180, it will be south, or 180 degrees. Okay? Now let's figure out the time. What time will we reach maximum altitude? So now let's look at our right ascension. Our right ascension says 16 hours and 30 minutes. So let's look up 16 hours and 30 minutes here. Looking at RA, okay, again, you're looking at RA for this. Oh, I found 16 hours. We've got 3 a.m. over there. But again, we have 30 minutes, so 3:30 a.m. is what time we will reach our maximum altitude. Okay, let's try another one. Number 2, we are going to use Cassiopeia. Okay, Cassiopeia has a right ascension of about, okay, I'm not using seconds here, we're only using hours and minutes. Cassiopeia has a right ascension of about 1 hour, okay, and its declination is plus 60 degrees. So let's start with maximum altitude, which is equal to the celestial equator plus the declination, which is equal to 37 degrees plus 60. which is going to give us 97 degrees. Okay, so remember we need to subtract that by 180. And that is going to give us 83 degrees. Okay, so that is when we will reach maximum altitude, is at 83 degrees. Okay, all right, so now let's figure out our direction. Are we going to be north or south? We are going to be north, or 0 degrees, because we had to subtract by 180, meaning we overshot the zenith. Okay? Alright, so now let's figure out what time will we reach that maximum altitude. Right, Cassiopeia has a right ascension of 1 hour. So let's go ahead and find 1 hour on the right ascension table. Up, 1 hour right here. Oh, look at that. It will be showing up at exactly noon, which is when our sun will also be at its highest point. Okay, which means we wouldn't be able to see Cassiopeia in the sky because it's going to be during the day. It's going to be bright. We're not going to really see any stars unless we're looking in a telescope at the time. Okay, so it's fairly simple. So let's give this a go for something else, because there's something very interesting that happens with time, especially when you are changing dates of exactly 2 months, 1 month, etc. Let's take a look at this, and you should notice this. We're going to do 3 dates here. And this is all going to be for Orion. Okay, Orion has a right ascension of about 5 hours and 30 minutes, and a declination of plus 0 degrees, meaning it's right on the celestial equator on our celestial sphere. Alright, so let's find our maximum altitude. So maximum altitude is going to be our celestial equator plus 0 degrees, or the declination. So 37 degrees plus 0 degrees, which equals 37 degrees. Okay? Direction is going to be south, or 180, because we did not subtract. It's not greater than 90. Okay? And this is going to remain the same for all of them. Now we're going to look at what time will it reach maximum altitude on 3 separate months. Okay, so our first month is going to be November 21st. Okay, so November 21st, we are going to go for January 21st. And we are going to go for March 21st. My apologies. Okay, so I'm not doing anything weird in here where I'm doing middle dates or anything like that. So let's look up at each one. November 21st is going to be right here. Okay, November 21st is 16 hours. What about January 21st? January 21st right here, 20 hours. And March 21st. Oh, here we go, 0 hours. Okay? So it's going to have the 16-hour start, 20-hour start, and 0-hour start. Okay? So remember, this is when the sun is going to be having its max altitude, is that right ascension. Okay? Alright. So let's start with November 21st. We have to fill in 16 hours. Okay, so we're going to stop once we hit 5, because right ascension for Orion is 5 hours and 30 minutes. So at 5 hours, we have hit 1 a.m. So at 5 hours and 30 minutes, we are now at 1:30 a.m. Okay? So now let's try again for January, where we will now be at 20 hours. Okay, again, we are going to stop once we hit 5 with the right ascension, which gives us 9 p.m. But because we are going to be half past 5, we will have 9:30 p.m. Okay? And let's go to our last one, which is going to be 0 hours. Okay. 0, 1, 2, 3, 4, 5. Okay, now we are at 5 p.m. So we will be 5:30 p.m. Alright. Okay, so one thing you're going to notice here is that we're skipping 2 months. 2 months, 2 months. Okay? And what you're going to find on this side is that each time it's going to jump 4 hours earlier. And that's an interesting concept that ends up happening. As you go 2 months later, you end up having your star rising 4 hours earlier each month. So whereas our star was originally going to be rising at 1:30 in the morning, which is something we would all be able to go outside and see, it is then going to be going to 9:30 p.m., which, depending on which part of the world you're in, if you're like all the way up in Alaska in summertime, for example, it's not going to work. But this is January, so it should be dark in pretty much most of, for example, the United States, which is where we will see Cassiopeia. It will be dark in most of the United States in winter at 9:30 p.m., so you will still be able to go out and see that star as long as you don't have too much light pollution. But in March, in most places, it's still light out at 5:30 p.m. You're not going to go outside and necessarily see Cassiopeia in the night sky, as it will be too light. So it is a very interesting fact how that happens. So to reiterate, things that we went over was that depending on where you are, that right ascension attached to your date is the beginning. It's where the sun will reach maximum altitude at that given time. That is the right ascension of the sun. And so that's what we use in order to determine what time our stars will reach their maximum altitude based on their right ascension. Okay? Thank you for joining me, and I hope you have a great day, and I'll see you guys next time.